After performing your chemistry practicals, this is the endpoint you are supposed to get, or something very close to this. You are provided with 8.6 cm cube of hydrochloric acid. You have 8.0 grams per dm cube of sodium bicarbonate, which I will call baking soda. Okay, so the reaction for these two will look like this. If you combine any triacylcarbonate with acid, you should get salt, water, and the carbon dioxide. So you have to keep that in mind. So this reaction will produce a salt, which is sodium chloride. It will produce water, which is H2O, and it's going to produce carbon dioxide, CO2. Okay. Now, the next thing I'm going to be very interested in is about this acid. The stock bottle of this acid, I say the stock bottle contains some information like the percentage purity. So the one I have here, the purity is about 36 to 38%. So this range, if you use 36, 37, there's no problem. But me, I choose to use 36%. So I have also the the molar mass of the acid, which is 1 plus 35.5, the one from hydrogen, and the 35.5 from chlorine. If you add this, you have 36.5 grams per mole. So this is the molar mass of the acid involved. Now, even though I need the density, but let's just look at how to find the molarity. Molarity of this substance of the acid is the percentage purity of the acid times the specific gravity, which I will call the relative density. Okay. Now divided by the molar mass, that value is about 1.18. That's the value you will see it in the stock bottle. So the density is about 1.1 grams. Then divided by the molar mass, which is 36.5, then times 10. Note this formula is very important in finding molarity. So the percentage purity of the substance is 36. We can use 37 or even 38. So 36 multiplied by the density of the substance, which is 1.18, divided by the molar mass, in this case is 36.5 grams per mole, then times 10. Alright? So if you multiply the numerators, you should get 424.8 divided by 36.5. Okay? So when you press your calculator, you should get 11.64 molar. So this is the molarity of the acid. So the molarity of the acid is, I will call it M, and that M is equal to 11.64, which is the mass we just solved. Okay? So now I'm going to write the dilution formula, because this is what I'm going to transfer into 1 dm cube of solution. Okay? Now M1V1 is equal to M2V2. We are looking for V2, which is the molar concentration of the acid. M is 11.64, which is the M1, times the given volume. WIAC has given us 8.6 cm cube. So this is the volume that is given. Then is equal to, we don't know the molar concentration of the acid, which is M2, but we know that the volume we want to use is 1000 cm cube, which is 1 dm cube of the solution, because that's the concentration of the acid in moles per dm cube. If you multiply the left side, you should get 100.10 is equal to, this is 1000 m2. Now I will divide both sides by 1000, which is the coefficient of m2. So 1001.10 divided by 100.10 divided by 1000, that will give you 0.1 moles per dm cube. So this is the molar concentration of the acid. Okay, so you have to know that the question that they must ask you, find the concentration of A in moles per dm cube, you should get 0.1. Now what I will do is, let's find the molar concentration of the base. Molar concentration is equal to mass concentration, okay, over molar mass. So let's get the molar mass of that acid, of the base first. The molar mass of the base is equal to 23 plus 1 plus carbon, which has 12, plus oxygen that has 16 times 3, and everything should add up to give you 84 grams per mole. So this is the mass concentration of the base, which means, sorry, the molar mass. So the molar mass in this case, okay, molar concentration, sorry, is equal to the mass concentration divided by the molar mass of the substance. Then the mass, remember, is given to us as 8 grams per dm cube, which is the mass concentration, and that 8 divided by the molar mass, this 8 comes from here, is provided by WAEC, then divided by the molar mass, and that's 84 grams per mole. And this will give us 0.0952 moles per dm cube. So this is the molar concentration of the base. So since we have been able to get these two concentrations, you can now be able to use your formula to get the other one you need. You understand? So what you do is, I will say, of course, this formula is no longer a new thing for you, okay, and that's equal to this other right side. Of course, nobody will say that you don't know about this. Now remember that we have Ca in the question, which we have solved for, times the expected volume you should get during the practicals, which is Va, now divided by that of the base, which we have calculated for 0.095, then times volume of the base, and that's 25, and everything is equal to, if you look at the equation you balanced before, you should know that the ratio is 1 to 1. So here is 0.1 Va is equal to, if you multiply these two, you should get 2.38, I think 2.38. Good. Now we divide both sides by the 0.1. 2.38 divided by 0.1 will give you 23.80. So this is the volume of the acid that you should get during the practicals. Anything you get far from here, you have to check